Good morning, good afternoon, or good evening, depending on where you are in the world. And welcome back to this learning experience brought to you by GitLab. My name is Cody, and thank you for joining us today on Techstrong Learning. We've got an exciting presentation ahead, but before we dive into things, I have just a couple of notes I'd like to review with everyone. First of all, we are recording our session today. So if you miss any of our conversation, if you'd like to rewatch at a later time, or of course, if you'd like to share this with your team, you will be receiving the recording via email shortly after we conclude this live session today. Now, if you would like to engage with us, if you'd like to be part of this presentation today, there are a couple of ways to get involved. The first way is to talk to us through the chat tab on the right side of your screen. So when you find that chat tab, I'd like you to let us know from where in the world you are joining from. If you have any specific questions, we want you to send those over in the Q&A tab on the right side of that chat section. We'll be holding most questions until the end, so you've got the whole session to send them in, but be sure to send in as many as you'd like because we do have plenty of time set aside to address them. And additionally, we will be selecting 2 of our most engaged attendees today to win a $50 Amazon gift card. So be sure to send in your chats, your questions, and of course, fill out our survey after the webinar concludes. So today we'll be discussing frictionless DevSecOps, reduce cost, accelerate DevSecOps maturity, and create developer joy. I'm joined today by Darwin Sonoy, Principal Partner Solutions Architect at GitLab Alliances. And I'm also joined today by Jason Mimic, Senior Partner Solutions Architect at GitLab. So Darwin and Jason, thank you both so much for joining us today on Techstrong Learning. Jason, would you like to get us started?
Yeah, for sure. Thanks a lot. And by the way, I work at AWS, so who's a great partner of GitLab. So we're working on this together. Yeah, we can kick off. We can get to the first slide. So, I'm going to do a little intro here, and Darwin's going to really dive into the meat, but got a few slides here to kind of set the stage. So why have technologies like serverless and containers become so popular? Well, to start, you can build distributed systems, each within its own control plane. The packaging of your application into standard container formats provides a way for security and transport services to integrate much more easily with your applications. And also the ability of the underlying platform allows you the ability to dynamically scale up and down, not just your compute, but your network and your storage needs, allowing you to really deliver a lot of value for your business. Go to the next. Thanks. So this is really where the cloud and DevOps come into play. The cloud offers, obviously everyone on this call is going to understand, so many benefits for deploying and managing applications at scale globally. And DevOps in general really encompasses all that work behind the scenes. Your end users, they don't know anything about DevOps, but everyone on your team, your supporting staff, and your organization greatly benefit from these practices. 2 really important benefits are abstraction and automation. The abstraction aspect allows your team and your organization to build uniform internal development processes and platforms so that different teams working on different applications can do the same thing in a similar way. And the automation really empowers this abstraction. Industry standards allow your team to leverage the ability of the platform to automatically, monitor your clusters and fix things. For example, if a pod goes down in Kubernetes, automatically a new one will spin up. With Lambda functions and serverless, there's ways you can automatically deploy your code directly from committing into source control. And all the other features that partners like GitLab provide allow you to really tailor this process exactly down to your specific needs with a lot of other features, alerts, logical checks, approvals, log retention, and things like this. Go to the next. But how do you really manage this securely when you get to scale? So often when large corporations and organizations adopt these ideas, the deployment architectures really, really quickly become complicated to manage, let alone scale out across multiple teams and services. Security is paramount in this aspect. And security really is priority zero here at AWS. Everything goes through multiple security vets, and this should be a top priority at your organization as well. But so we understand the challenge and that you all face being able to manage all these requirements around security and for all your different teams. It's truly an exponential problem. You have multiple people, multiple roles, multiple needs, multiple different services, environments, and it's complicated to manage at scale. And that's really why DevOps and what you'll learn more about DevSecOps is really, really important to build in from the very start. And the breadth of services and platform that AWS provides, along with the control that you're going to learn a little bit more about from Darwin, that an insight that GitLab provides, is something which can really, really accelerate your organization's ability to scale and manage complex deployments with complicated security requirements, which ultimately is really going to allow you and your organization to deliver better results faster, which are secure. So with that, I'd like to turn things over to Darwin from GitLab for a deeper dive into DevSecOps and how to reduce the friction for your teams to successfully implement these concepts.
Thanks a lot, Jason. As a partner solutions architect at GitLab, I have the great pleasure of working a lot with our Amazon Alliance partnership. And I want to just highlight that one of the things I've found in dealing with that is we have a lot of technological commonalities. We release customer value constantly. We have a lot of interesting ways of approaching platforming, but we also have a lot of cultural similarities in terms of really embracing a lot of the fundamental aspects of DevOps within our own organizations as we create solutions for the marketplace. So I really appreciate that cultural commonality that we have with our partner AWS. So I'm just going to try to take you through a vision of secure development, frictionless business as usual habit on the part of developers. And if you look at the presentation title, you might say, well, how am I going to increase velocity, increase happiness, and also reduce costs at the same time? It sounds like one of those impossible paradigms of optimization. But I want to point out that as we go through here, we're going to make some fundamental changes. And so a lot of times these ability to unlock such efficiencies comes with some fundamental changes. And we're going to talk about what those fundamental differences are with GitLab's solution approach to this problem. So as we go through, you'll see that we want to talk about a platforming approach to AI. So within GitLab, the DevSecOps platform, we take a platforming approach to a lot of concerns and considerations. And we also have obviously embedded security at the deepest level. We actually changed branding from DevOps platform to DevSecOps platform to emphasize how much we take this seriously. We also platform compliance into the solution, platform collaboration into our solution. So these aspects of platform don't just stop with the idea of DevOps. You start to platform all cross-cutting concerns within the GitLab platform. We also want to solve for DevSecOps with the extensible DevSecOps platform. We'll talk a little bit about how when you try to solve this in an incremental, get started yourself way, you can end up creating something that's rather unwieldy for yourself. We also want to talk a lot about how human habit psychology indicates that there's some specific places we want to insert DevSecOps into the entire development lifecycle. If you've ever analyzed anything with human psychology, it's the kind of thing that if something's true of human psychology, you can either align with it or you can be run over by it. And so I think in our traditional approaches to security, we've kind of been run over by the fact that human habit psychology is not being appropriately accounted for in how we build this out. We'll talk about what I call an empowered shift left. And basically, we bring everything into the right context with the right timing. And so that's super important. I'm also going to emphasize how DevSecOps maturity has to be roadmapped. And this is really important so you know that when you're done. If you go on a driving journey and you don't map out where you're going, you never really know when you've arrived. And this aspect of DevSecOps maturity is important enough that you really want to know when you can claim back to the organization and to your customers, hey, we have a level of DevSecOps maturity that we think will stand the test of time. And then finally, when we talk about automation, it's frequently emphasized that we boil things right down to machine automation. Super important first principle of automation. But the second principle of automation is for those things that you cannot or should not turn into complete machine automation, you can still apply automation. You've typically heard this called workflow. And so GitLab continues to go beyond just machine automation into making sure that critical human workflows can also be automated. So I'd first like to just dive into GitLab's developing vision of AI. And one of the things we did was poll our customers, and I think you'll also find this was a popular polling question in some other polls as well. We wanted to find out, as far as generative code AI assistance, what amount of time are you spending on coding? And for better or for worse, the average came out at 25%. There's a lot of other duties developers do to make sure that what they do in coding gets out there and is done well. There's a lot of team management. There's a lot of various other activities. Some organizations target this metric and expand the amount of time that developers spend developing. And some organizations, it's much worse than 25%. But you have to realize that that's just part of the cycle. So if we only apply AI to that one part of the cycle, and let's say we had a 4x productivity improvement in coding, the rest of the developers' activities, and then the rest of the entire DevOps workflow is not necessarily expanding to account for that. So at GitLab, we try to apply AI power to the entire DevOps routines, the entire cycle. And this is an aspect of how we platform within the platform. So we always take an approach of platforming when it comes to cross-cutting concerns that we build into the DevSecOps platform. Here's an example. So as we're bringing features online, we have been bringing them online across the entirety of this cycle. On the slide here, you can see that explain this vulnerability, explain this code, and suggested reviewers are all aspects of improving security. But we want to make sure that we can improve the complete throughput of the system with AI, not just balloon the productivity of one part of it. So that's an important aspect of how GitLab is platforming AI into our platform. I want to just talk a little bit about some of the patterns we see in organizations. So frequently, when organizations start going down a DevSecOps road, they don't necessarily bring forward the lessons from DevOps. So they might have a really reasonable DevOps approach in place, but frequently they start from scratch. Sometimes this is because DevSecOps starts outside of the teams and groups that deal with the DevOps aspect of the organization. But this really ends up repeating the cycle that we had in do-it-yourself DevOps, which was that we end up with a Rube Goldberg machine with a lot of unnecessary process delays, a lack of automation, a lack of security process automation. And so an organically engineered DevSecOps can end up really going back in time and using some old methods that we should probably leave in the past. So GitLab really believes that when you start on something that is really a subset of DevOps, you should start from platform. So we have the DevSecOps platform, and we think that that's where you should start, even if you're a small company. The interesting thing is that, like Amazon, GitLab's platform is extensible. So it's not just about providing you with an opinion that allows you to move forward. That opinion is not rigid, and in key ways, you can extend that platform. Platforming is all about shifting undifferentiated coding away from the smart people that you employ in order to solve business problems for your customers. And so actually developers have been doing this from time immemorial. So if we take a language like developing in Ruby, What ends up developing over time is the concept of shared componentry. Uh, Open source components, even building your own custom components, where you can have a level of reusability. In addition, we end up with frameworks that are on top of that. And those frameworks allow for you to then handle other concerns that aren't essentially customer facing value at that level. So for instance, in this stack, if we were just to think about, hey, you know what, we need to have some database functionality for our app. We're going to start storing some state data. When you take a platform approach, you'd start at the top of the stack and you'd say, is there anything that handles a reasonable amount of database functionality already built into this top level? No, there isn't. Do we have a set of Ruby gems that allow us database functionality so we don't have to write and maintain that? So we're really offloading that undifferentiated coding to a platform aspect of this language stack. Well, Amazon's been doing the same thing in operational excellence, scalability, and security of operations infrastructures. So Amazon has shown the world that it's appropriate and very accelerating to your organization to take a platforming approach. And once again, with this stack, you start at the top to understand, is there a service in Amazon that handles 99% of my concerns, amplifies an example of a concern that tries to really abstract a lot of the back end and front end aspects of Amazon services so that your developers can focus on application delivery. If that's not sufficient or you need a more granular level, well, then you can get down into the individual services and assemble them in a way that works for you. So the same kind of platforming approach. Well, GitLab is taking this platforming approach in DevSecOps. So we build up a DevSecOps platform base, and then within that, we have additional platforming. CI/CD, we basically apply a platforming approach to CI/CD, to compliance, and to security. And this is all really about extending or shifting architecture left. Now, in this diagram, I have an arrow that's pointing up that says left. It's kind of hard to get both these concepts across, but basically, you're taking pre-architected bits and allowing developers to leverage them whenever they can. So this is a major shift because architecture is not an easy part. One of the interesting effects that you see in Amazon and other frameworks in GitLab is it can scale with your business success. So as you have more customers, more requirements, more of everything, these solutions are able to scale out for you. Just another aspect of platform power. So when we're building our software, we start with small custom nuggets, and then we build that out to an eventual large custom code base, always as small as possible, but the code base being proportional to the customer value of our solution. Now, for the code that is what we are providing to customers, that they pay us for value, this is great. This is the exact kind of evolution that we want. However, when there's a platform available, this is really a sort of an internal platforming that may be unnecessary, or you may be able to do an internal platforming effort that takes advantage of an existing platform, similar to how developers would use Ruby gems or Rails instead of building something themselves in that language. Well, when you take a platform first approach, you look at the most abstracted level of the platform to understand if it has what you need. And then if it doesn't, you see what minimal changes can you make to make it be appropriate. So that extensibility is super important in adopting platform. If you adopt a non-extensible platform, this challenge becomes very difficult because you have an over-opinionated situation and you feel fenced in, and eventually you go to full-on manual build for yourself. So it's important that that platform be extensible, but this really reflects lean engineering of your DevOps. And lean engineering is beneficial to both small organizations and startups, as well as to those who are trying to do digital transformation and get back to a focus on customer value at all times, including in their software development. And so this is really a shared value between GitLab and AWS, is that we take a platform first development approach, and we also try to provide you with platform bits and pieces that can do the same for you. So that's just an aspect of how we're platforming and how platforming applies to GitLab and how it might benefit you. I'm going to talk a little bit about the aspect of habits and how they play into how we can gain a lot of simultaneous benefits for doing DevSecOps. So these two books are two of the most famous books that have come out in recent years about the psychology of human habits. And they encourage us that taking up small, tiny little habits during our daily life end up adding up to a sizable impact. and end up adding to our lives in substantial ways. But we have to be committed to those little changes. But they not only talk about that, they actually talk about the mechanics of how habits work. And so I'm going to walk you through what these books say about the concept of how habits are either never formed or destroyed. And we're going to talk about it in the context of security. And then how these books say that habits can be formed, as well as how we can do something really interesting called habit stacking. So if we want a habit to never form, then our cue that it's time to do a routine would be invisible or hard to understand that it's the right time. And when we think about security scanning, this is when security scanning is a separate process or happens way down the process from where the work actually occurs. So everyone merges to one shared branch, and finally we do security scanning weeks after everyone's worked out their functionality, merged all their code into a common base. Now we do that scanning. So that separated scan is very similar to this. Also, if a routine is difficult to engage in, a habit will not form. And we see this a lot in DevSecOps, and we have vulnerability reports that come later. They're out of date. We see non-collaborative communication. If any of you have ever been stuck on a thread where there's an attached spreadsheet with vulnerabilities, and there's 5 versions of it attached to the thread, and you're trying to figure out and answer the question, is vulnerability in line 72 of the spreadsheet addressed? And it takes many people hours and a couple weeks to establish it. It was actually addressed 4 hours after it was found. Those kind of things add a lot of difficult engagement, and especially unclear code responsibility when we've merged everything to the same branch before scanning. And then if a reward is unsatisfying, that will also prevent the habit loop from closing. And so a lot of times the traditional remediation management, we don't celebrate that you've been able to eliminate something from your code that is a vulnerability. And so this doesn't allow a habit to form. In fact, this is how you dismantle a habit. This is if you have a negative habit in your life, you dismantle the habit. So you don't have the potato chips on the counter. You hide them out of sight. So you make that cue invisible. You put the potato chips inside of a safe so that you have to go through some hassle to get to them. And maybe you, I don't know, sprinkle some hot pepper on your potato chips. So the next time you have them, you have an unsatisfying reward for having engaged in that. So this is also how you dismantle a habit. So it's pretty serious as far as how this affects human thinking. On the positive side, if we have an obvious cue, and developers already have an obvious cue in their routines of pushing code, they want to get that additional feedback from the CI system. And then if you make sure that engagement is easy. So with developers on resolving build failures, engagement is usually made as easy as possible, usually in that merge request view where they can see how to engage. And then finally, if the reward is satisfying, then that's helpful. That causes a habit to build. And in the case of developers' normal daily habits, this is when they get a clean build. Hey, nothing's broken. My code's looking good. And we get that completion of that habit formulation. So developers already have this habit loop. It's already going on in most organizations. And with DevSecOps, one of the ways we can insert it is to do habit stacking, which means we don't need a whole new habit loop in order to account for this. We add a new routine to an existing habit loop. So here we're going to add remediate vulnerabilities to their existing daily habit loop. And that's how we get the vulnerability remediation habit to form within the very folks that always have to be the ones changing the code. Let's take a quick look at how this intersects with the GitLab's overall workflow. You may know that GitLab has work management built in, but one thing you may not know is that GitLab Flow calls for developers' first course of action when they're about to code is to take an issue, assign it to themselves, and create a merge request, which also creates a feature branch for them. This merge request becomes their single source of truth for all the information about collaboration and feedback on the quality of their code and possible things they should pay attention to. When they push that code, we have another very interesting capability that sometimes folks miss. This is integrated environments as code. So we can stand up an environment that is a DevOps-like environment for them. This is not a developer environment. A developer environment would happen on this diagram back where the word feature branch is on the squiggly line there. This is actually a full-on production-like environment. And it's using the same code for infrastructure as code that will deploy to production. And that's important because frequently development teams add a new service or need a different setting on a service in the cloud. and that needs to happen in infrastructure as code. When these are unified, we can move environments as code all the way left into the merge request, as well as be testing that code in every stage instead of as a separate activity. These environments, however, allow us to bring back a complete set of results. So now we can do DAST, API fuzzing, we can do any kind of testing that requires a running copy of the application and get that back to the developer. Now, one interesting thing here is this merge request and all the scans are analyzing only the code the developers changed in the merge request. So we disambiguate all the noise of findings that might be in the software that haven't been addressed yet. So they know if there's a new finding, they caused that finding, usually inadvertently by using an older version of a component or a module or something, and they're more than willing to fix it at that point. As we go through the collaborative review process and more approvals are got, we get to the point where developers are then pushing changes based on collaborative review. And when they do that, that environment's refreshed and all of our scanning is refreshed. So they get to see what else they may need to address. So we don't get into a situation where we address one vulnerability and the new one was introduced, we don't know it, and it slips by. As we move forward, we get all the approvals from all the stakeholders, and then eventually we merge. And here's where GitLab's environment as code support does something really interesting. When we do a merge delete branch, we go back and clean up that environment. A lot of times when I speak to folks and tell them about this, they say, well, our developers will never let us delete environments arbitrarily like that. Well, in reality, that's because usually there's been a lot of process put in front of them so they can't get environments. And then when they can't get environments, they leave them hang around, which causes us to add more process because it's getting more and more expensive. I've been in one organization where the sprawl of development environments was 10x as expensive as the production versions of those applications. So this becomes a negative cycle when we don't know when we can delete it and we don't delete it automatically. So at merge delete, we know the person who built the environment is also done with it and we can delete it. That person's not going to resist the process because how do you get a new environment? You create a new merge request. And so this is a very interesting capability that GitLab has had to move all the way left into the merge request development processes, environments as code. And that's one of those things I was talking about where when you shift some fundamental things that aren't expected all the way into an empowered shift left, new things are possible as far as efficiency and developer joy. I want to take a look now at the merge request. So this is a merge request that has the security findings within it. And I want to just point out some things. So this is the developer. You can see at the top, they have a successful build, 3 green check marks. So they're getting that positive feedback. But now they have these findings in security. And notice here that they have these findings in their context and they can triage them. Another thing to notice, these are actually findings from Amazon Code Guru. So GitLab is extensible and the Amazon Code Guru team took it upon themselves to express the findings in GitLab's findings format, our SAS JSON report format. And then we can collect those in a pipeline. And so in this situation, these are actually being found by Amazon Code Guru. But not only that, our merge approval security rules are also being based upon those findings from Amazon Code Guru. Now, merge approval rules are super important. I talked about earlier about how developers are frequently subject to this situation where their builds are failed when they have security findings, but this stops all of their productivity. If you think of a situation where they have a security finding and that security finding is something they don't know how to deal with, well, if their builds are failing, in order to stop them from moving this code forward, also all their other productivity stops until they can find out how to fix that. And eventually and frequently, this causes directors of development to remove this out of the process because we can't impact developers' productivity to that level. Well, in GitLab, all the CI can keep running and the findings can keep being found, and all findings from all tools can be registered instead of just the earliest finding that's possible. And we can still prevent that code from moving forward. And in this case, this is a threshold-based merge approval. If this developer eliminates these 3 critical findings, this rule automatically becomes optional and security doesn't even have to know about it. And then if security does have to know about it, if the developer asserts, I gotta have this merged, then when that happens, we have a basis from which to have that conversation, and security is only asked in when they're actually need to be. Let's take a look at what happens if we were to click one of those vulnerability objects that was in that list. we get a very thoroughgoing collaborative capability and feedback in each vulnerability. In this case, we're seeing that there's some solution code, so the developer can apply the solution code. In a few cases, there'll be a button that just says, solve this by upgrading a component. We can also see down here that we have on-the-spot, on-demand training. We have 3 training providers that you can turn on, and the developer can train on just this vulnerability. So we're not expecting them to become a comprehensive expert, but they can become more schooled in this specific vulnerability, this specific time to get it through. And that's a great agile way to learn as well. You can also see here, they can start interacting on this vulnerability in a collaborative way right away. They can dismiss it. They might say, hey, this is a web-based vulnerability and we never use this component facing the web. So they can interact, and then security can see those and respond, or team leads. But if it's more elaborate than that and you need full collaborative capabilities, you can also create an issue here, in which case all of those findings are copied over into that collaboration object. Now, let's talk a little bit about shift left. We hear a lot of shift left. You start hearing it so much that your mind actually screens it right out, because it starts to mean nothing. Everyone's claiming shift left for everything, but they never get down to details. So let's talk about, what does an empowered shift left mean in terms of exactly when and exactly what do we need to shift left? So when we're not shifted left, we have this experience. The kind of checks that we need are happening after everything's been assembled. These individual engineers have worked on various parts of this particular software, and now it's fully assembled, and you're telling them, hey, you got to take this thing apart and address these problems. Bad situation, you get a lot of resistance. You're not in context with the developer's way of working. Now, earlier, if we can shift this all the way to when the developer is building that fundamental functional capability, and we tell them we have a finding, they're more than willing to address it. Developers want to be excellent at their work, and they want to not be the one to introduce a vulnerability. And so if we can give them the right information at the right time, they are more than willing to engage. So the things we're shifting left are, first, agile transparency. Create that merge request, have an environment, get all the automated feedback and collaborative capabilities online as soon as possible. We're also shifting left environment as code. So those small environments that allow every developer to have an isolated environment from every other developer and get all the feedback on all findings about just the code they changed. We also have a completeness. So because of that environment as code capability, we get all of the findings, not just the static findings, and then later in a shared branch, we get all the dynamic findings. There's also clear responsibility. This developer created the commit, they created the branch, and they created the merge request. Or potentially this is a team, but we can also see what developers created, what commits. So clear responsibility for any newly introduced vulnerabilities. We also move the security controls left so that we can prevent moving that code forward without impacting developer productivity. Teamwork is moved left through collaboration. And sometimes we forget this, that if your DevSecOps solution or your approach to it is not ensuring full collaboration capabilities are preserved, at least the same ones that you have over your code system, then you're lacking a lot of workflow automation. So it's important that collaboration shifts left with us. Then we have that on-demand training that I highlighted. So putting developers in a position to figure out what's wrong with their code on their own if they have the time and orientation to do so. And then there's AI aids. So anytime we have AI, we bring that as far left as possible, thinking about all the places that we can inject that. And so another aspect of this too is, while we're shifted left into feature development and merge requests, after each push, all the CI results are refreshed. So we're really getting a per push shift left. I made some code changes, I pushed them, and so we inherit that really excellent per push feedback that updates all of the findings. And then also a key part of this is all the parts are still on the workbench. If you fully assemble a piece of IKEA furniture and someone says, hey, you got that part there upside down, or you know that screw you used over there, it's about to break. It's kind of frustrating. You have to take it all apart. But when things are still on the bench and you just got the parts out and someone says, hey, you know what, that you're going to put that in wrong, you're more than open to handling it at that point. So this timing aspect is super important. And all of this by tapping into the right place where developers do their daily grind and work to create the value they're trying to create for your customers. We tap into their excellence motivations by giving them the right tooling, that fully empowered shift left with the right context at the right time. So what's happening here? The book Atomic Habits talks about environment as the invisible hand that shapes human behavior. And environment, in my opinion, is another way of saying rich context. So when you're in a certain context, if you're in a certain room, you know what this purpose is by looking around at the furnishings. So the environment here, what we're doing is within their everyday developer habit loop. So we have them in context, in a habit that they're already well established for code changes they made only moments ago. So that we're only looking at code that they've changed. And in the case of a new push, the code that they just changed. Only newly introduced vulnerabilities are immediately visible and directly associated with that individual in a positive way. It's a positive aspect to know that something that you're building needs to be fixed or needs to be worked on. They have a semi-private remediation opportunity. So because security and the organization knows they're not going to be able to push that code forward if it doesn't meet our security policy, no one has to come and start hammering on anyone while they're still working on something. And we don't have to run into the situations where someone's contacting a developer about a vulnerability only to find out, well, they fixed it 5 minutes after it was introduced. So that alerting is inappropriate. We also have auto remediations, on-demand training. We have the collaborative capabilities, the full collaborative capabilities of DevOps also shifted into that context. When we do this, the net result is that remediation management defaults to the developer. And when we say remediation management, pardon me, I don't mean the actual aspect of coding. The developer always has to do the coding part because if something else breaks, you're going to have to fix it. Remediation management is who is going to be responsible to make sure remediation happens. And when we can't shift this into the right context for developers, they are powerless to actually take responsibility to make sure they drive findings out of their software as soon as they're introduced. So if you have the right side traditional remediation management, most of these aspects flip on their head and become negative. I want to be clear that GitLab has traditional remediation management through our security dashboards, and it's necessary. So traditional remediation management is much better than no remediation management, and it is a necessary reality. However, it's not an optimal reality. And so when we create the situation on the left, we make this much better. Also notice that when remediation management is out of context, then also the aspects of reporting on remediation are out of context. The remediation management also falls out of the context of the developer. And so now frequently to get better at DevSecOps, we are having to create more hires in the security department. And a lot of the work ends up being just chasing to make sure that remediation actually happens. So you have to consider this as a part of your whole DevSecOps maturity. And DevSecOps maturity should really be roadmapped or planned. And like I mentioned before, if you don't roadmap it, you won't know when you've gotten to good enough. And it's important not to treat security as it's never good enough because eventually it can grind the entire organization to a halt if we get too risk avoidant. But it is important to be able to give an account to your organization, to your customers, and potentially to regulatory bodies, that your DevSecOps process is indeed mature. And so when you step out into this, what we see with most customers is that maturity generally means more of your teams doing more types of scanning more often for more lines of code and more languages in their growing total code base over time. So it generally means a lot more scanning. And if that scanning is out of context, it's going to be very hard to address that. When companies start to go down this road in a do-it-yourself format, which happens quite frequently because your initial needs are small. So it looks like an agile problem, right? My initial needs are small, so let me just put something small in place. But then as you try to work forward to account for all of this maturity capability, you run into some pain points. So tool set complexity is one of those. How many tools do you have and how do the developers navigate between them? Implementation costs, even if the tools themselves are free, implementing them, standing them up is not free. Remediation management hires that we just talked about. Where is remediation management going to happen? Is it going to happen at the seat of where the problem was introduced, or is it going to happen after that? Developer learning curves. So learning curves in this area are not directly customer value creating. So if we can keep that learning curve low by keeping it in context with tooling they already use, then this is super helpful. Your developer onboarding costs, which was identified in our AI graph, go down because developers have one place, one UI, one metaphor to deal with. Any of these stacks that you stand up to help with security tooling need their own administration, patching, and upgrades. Sometimes that involves licensing costs, but even just the managing it as a service costs start to stack up. Your code base grows. Some organizations have usage-based pricing on some of the tooling that they implement. I've seen situations where customers run through with a tool for the year, do their coding, come up with a price tag in the tens of Ks, and then go to get a quote for what they think their total activity will be. And all of a sudden, it introduces many multipliers of that number in order to get there. Also, usage-based pricing can suppress your best practices of scanning more, scanning earlier, scanning more stuff. And so this is another possible challenge. And then finally, non-automated process. So we know that DevOps is about people, process, and technology. We definitely want to automate the technology. And as much as possible, we want to take the process and turn it into pure machine automation. But when we can't, we need rich workflow controls in order to make sure that what remains of process is actually automated as possible and smooth and hitchless as possible and doesn't cause unnecessary value stream delays. Interestingly, this all not only ends up being a map of pain points, it ends up being a map of total cost of ownership. And if you understand total cost of ownership, it's not just about initial acquisition and getting this stuff in place, it's about ongoing costs. Many organizations at one of these pain points hit a stop from somewhere in their company. No more money for hiring people, no more tools, too much developer productivity impact. So it has to be, you have to be very careful about building this yourself. GitLab, we really feel that you can easily run into compounding penalties for getting better at DevSecOps, and that can be a really bad effect. At GitLab, this curve stays flat. You are paying by number of developers, and those developers are actually the people in your organization who are doing value generation in software. So if you have a large code base that you have to keep maintained, you don't get penalized by scanning that a lot to make sure that new vulnerabilities in the wild are not in that software. So GitLab attaches its pricing to your value generating activities, the folks who are actually in your systems building out great value. So just really want to think about, DevSecOps maturity really needs to be roadmapped so that you know where you want to go and what time frame. We run into customers who don't do this, and what ends up happening is this turns into a dash, a sprint, a 100-meter sprint. And that's because they actually have a security incident. And all of a sudden, the hammer comes down that you need to address this. Now, if you are on GitLab, and you don't have the security features, the cool thing is it's just a key switch away to turn this on and get a lot of DevSecOps maturity overnight if you have no process. But also, even if you have a defined process, making sure that GitLab can lift the undifferentiated heavy lifting of your security process as much as possible can really cause an acceleration of this process and an acceleration of realization of your version of DevSecOps maturity. I want to just talk a minute about our workflow control. So this is a workflow control parts list. I'm not actually going to talk you through the details. There is a video on GitLab's Unfiltered channel that goes through the details of this. But what I want to show you is that each of these purple boxes is an aspect of introducing workflow control. Some of them are very automated, machine-oriented. Some of them take into account the fact of human intervention and human approval. And all of it allows you to be more assured about what it is that you are publishing and making sure that software is really ready to go, is really secure, is really high quality. And so when you think about a platform that is allowing you to do this, GitLab is really platforming the concept of workflow controls. This is mostly GitOps. You can see we're using branches here to merge to environments, but everything in the bottom right side of the diagram is actually value add above GitOps. So you could call this GitOps plus. These deployment approvers, deployment windows, and other things are things that aren't actually built into Git, but that GitLab has built into the solution in order to make sure that you have the workflow controls that you need. So let's do a bit of a recap about what we've been talking about. You want to take a platforming approach to AI. You want to make sure that you're looking at how does it need to impact everything so that the productivity benefits of code gen are actually realized. Because if we just focus on code gen, get that up and running, we're going to have a lot of frustrated developers who are now more productive and are backlogged by all the other things in the system. You also want to solve DevSecOps with an extensible DevSecOps platform. You may have seen that on Amazon, they'll give a demo of one single developer on the free tier builds out something cool in serverless. And then in 2 months, they go to production with unlimited scalability. So platform approaches are not actually only for large organizations. They're very much for small organizations, and they very much scale with your customer success. The habit fast path to getting developers more engaged in security is to attach their existing habit loop. You want to align with fundamental human psychology. If you decide to go against fundamental human psychology, you're not going to win. These things are embedded deeply into what humans are. And so it's best to align. It's also important to realize that because GitLab's extensible, you can introduce security scanners that you need so that they can still cause early developer engagement in context and still have other benefits if you have other benefits of security tooling that you already use or are thinking of using. We also want that empowered shift left, in context everything. Align with how the developers work and put the things in context that you need them to pay attention to. Most importantly, you want them to only have to deal with things that's in code that they have changed. So that Delta capability is an important part of that. Also want to note that DevSecOps maturity has to be roadmapped. You only know when you've arrived at your destination if you actually roadmapped out where you're going. And so this is an important aspect. And once you do that roadmap, now you can compare the various solutions in the market and various approaches to building out this functionality and get an accurate apples to apples comparison of what are going to be the true total costs of various approaches to making sure that you have DevSecOps maturity. Finally, when we can't automate things into pure machine automation, which should always be our ardent focus, it's important not to then throw up our hands and say, okay, it's going to be a messy human process. We can still apply automation to human workflows as much as possible, and GitLab also platforms this aspect of interaction. So I hope that you see that how making some fundamental innovations in aligning with developers' natural instincts, their desire for excellence, you can see that we can potentially make positive impacts to all three of these areas, reducing costs, accelerating our DevSecOps maturity, and creating developer joy, or at least not making it a sour experience or a hard experience. So I hope that going through this has helped you with that. We're now going to break and handle some questions. So thank you for your attention.
Awesome. Excellent, Darwin. So we have received a few questions thus far. So anyone in our audience, feel free to continue sending them in, and we'll take the ones that we have from the top. So this one came early on in the program from Gabriel. One question that comes to my mind right away: how GitLab differs from native CI/CD and DevSecOps offering from AWS. Which advantages do we have in comparison with GitLab?
So as our partner SA, I have to make myself very familiar with these offerings for a variety of reasons, for customers who are moving between them, or customers who have dependencies on Amazon development tooling that need to retain those for a variety of different reasons. I would say that the power of the Amazon platform has been the ability to make complex assemblies out of lots of primitive parts. And in code suite tooling, we see this. The challenge is that you still have a fair amount of time that you spend on keeping that platform maintained. So even though you're using nice big chunks that are scalable, you're still, when you need to, say, add a new pipeline or a new aspect of pipelines, it takes someone who's pretty knowledgeable of the framework and the platform. And this is also true of newer offerings from Amazon, that it takes an infrastructure professional who's also very understanding of how DevOps and development works in order to create some of these capabilities. So I guess the way to say it is GitLab is more out of the box-ish around DevSecOps considerations. You can configure things with fewer clicks and less knowledge about the target platform in Amazon.
Yeah, I
Awesome.
would concur with that. Like, you got a lot more features, like with a lot of AWS services. We got the core building blocks and they're rock solid, but it's not always as easy to use on the very last mile, especially at scale with new team members and things like that. So yeah, no, totally agree.
Awesome. Thanks for that, guys. Our next question comes from Steve. And with AI getting popular, even schools are slowly allowing students to use AI. My first impression is that developers are getting lazy and perhaps quote unquote stupid as they don't try to think before seeking help. What do you think this will impact developers in the long run?
I mean, one thing that when I talk to folks about AI and code gen is you can think about it as a junior colleague. Um, well, first of all, we need the capability for the suggestions to honor what is in the code base, and GitLab's developing that. Amazon has that in Code Whisperer customization capability, and GitLab's compatible with customer customization capability. So the first thing is a junior person on your team, say an intern, might generate some really cool code and not realize, oh, you've got to like totally upgrade your version of npm or some other fundamental aspect in order to use their new code. And this is what AI will come up with by default. AI is being made more security conscious, but it also can come up with code that is fundamentally not secure because it's just consuming what it can see in the wild. So AI code gen does not reduce the need for expert oversight by both lots of automated checks as well as human collaboration. You're not going to eliminate your senior people and employ a sea of interns that then generate rock solid scalable code day in and day out with AI. So just keep that in mind that yeah, the lazy developers, their work will be known when it can't scale, when it's insecure. So if it makes people lazy, it'll be shown. If you have proper DevSecOps processes, it'll be shown that they're being lazy, and or that your team's not working together as a team.
Yeah, it'll never replace a human brain. It's totally an assistant, and we'll get through this first hump of it.
Yeah, I know we've got some big growing pains with AI coming in. So yeah, absolutely understand that. Moving to our next question from Yavor. When it comes to cultural shifts, what strategies can be employed to foster a culture where security is a shared responsibility among all team members, not just a task for the security team?
Yeah, I think through the whole theme of the presentation, the idea is that we want to shift into the developer's context at the right time with the right things and the right information and the right tools and collaboration. And if we're shifting in and showing, hey, it's the code that you just changed, no judgment why or how, but it's got vulnerabilities in it. Everyone will engage. It's if you're making something in your garage or you're making something in your kitchen, you don't purposely dump the wrong ingredients in it and have people have a horrible experience with that. And so if you just get that information at the right time, it's natural for people to engage in doing what they do with excellence. If you run into a few individuals who aren't that way, well, then maybe they're not appropriate for your culture. But by and large, most people want to crank out excellent things, and I think we just get into that into the right place in their process, that cultural shift will be very natural.
Totally. Like if you bake, especially when it's baked into like a real intuitive user interface, like GitLab offers, that allows new people to get up to speed quick and they can interact with these complicated security decisions and things, but in an automated way. So they're not necessarily being called out by their peers or mentors if they're like new. This is very valuable. They can understand how to work autonomously, and the whole team is collaborating and making sure everything is being checked and all the boxes are being filled in. So
Yeah, so it's kind of like shifting to more of a blameless culture will kind of help the whole team grow as a unit is kind of what you're saying there.
Yeah, yeah, absolutely. And that the autonomy that you have to be able to work on things on your own in your own branch and get these reminders and clean it up. You can submit like good code and you're learning the whole way. Like even if you're using AI on the side, you're still learning because there's a real check in there.
Awesome. Well, it looks like we have 2 questions left, guys, so we'll kind of speed up as we go through them a little bit. Edward asks, what service is being used to check for vulnerabilities?
So out of the box, and this is similar to Amazon as well, Amazon out of the box provides you with some really good baseline capabilities. If you're a startup and you have nothing, Amazon out of the box logging is great. But then if you grow to the point where your logging needs become really big, they have lots of great partners who can plug in and you can start using their logging and reporting engines. GitLab is the same. Out of the box, we have over 20 scanners, support uh, all kinds of languages. It's all in our SAST list on the web. A lot of them are open source scanners that we then put structure around. Some are scanners we bought and are developing ourselves. For instance, the API fuzzing is that way. But then I purposely showed Amazon Code Gurus plugging in because the Code Guru team plugged in and they have full capability within our ecosystem. Interestingly, even if you have a third-party product and they have not built a GitLab CI connection, if you can massage their data format into our format, you can easily create your own plugin for a scanner that is third-party that you use or anything custom that you use. So that extensibility piece really means we got a lot of stuff out of the box. If you Google GitLab SAST, you'll find the list of exactly what scanners we use for what languages. And then you can know that you can plug anything else in. It's also made efficient by if you don't have files that scanner analyzes, it will never trigger that scanner. So there's workflow rules that judge, hey, you don't have any .NET code in here. We're not going to do any .NET code scanning. So those are kind of the ways that it works. And it's all transparent and documented when you dig into our website. It's not something that's opaque. Of course, if you've seen a demo of it, it looks like, oh wow, it went through these 10 scanners. How did it pick them? Where are they coming from? But it's all documented out there for you.
Awesome. Well, our final question is in regards to high compliance or high regulation sectors. But how does GitLab support the inclusion of specific security requirements, i.e., for the healthcare industry, into the pipeline?
So I mentioned that we're platforming compliance. One aspect of this is something called compliance pipelines, and it was on that workflow list where you can, by policy, say every CI job that runs must run this job, and then collect those results, and then they flow up through security dashboards. But we also have a separate initiative where you can take a repository and mark it as needing to comply with PII or needing to comply with healthcare standards. And we're developing that capability that you can have, we can start hanging reporting and CI capabilities off of that. So you can look at our futures page on being able to apply actual specific standards to actual specific coding projects and start to get a handle on how those projects should be managed, and attaching your own functionality when you encounter that'll be exposed in the CI pipeline. So you'd be able to say, if you see this flag for this compliance framework, I want you to run these 5 jobs that we've made. And then GitLab will come out with more embedded functionality over time for the same thing.
All right. Well, Jason and Darwin, that is all the time we have today. So we are going to have to start wrapping things up. But I really appreciate the 2 of you joining us here on Techstrong Learning today. It's been such an action-packed hour.
Thank you, Cody.
Yeah. Thanks a lot.
Thank you, Jason. And I just want to really show a lot of appreciation for AWS and the partner they've been to us. Great relationship. And we just want you to know that both companies are sold out to your success and that we're working together to try to ensure that.
Oh, thank you. Likewise as well. Hope everyone has safe and good holiday times wherever you are and whatever you celebrate. And thanks a lot, Cody.
Of course. Well, once again, thank you both. For our audience, I would like to remind everyone that we have been recording our session today. You'll be receiving this recording via email here shortly, but you can also find it living on the DevOps website. Just visit devops.com/webinars, and it will be in the on-demand section. A couple of final notes. We will be selecting 2 winners to receive a $50 Amazon gift card. So be sure to fill out your post-webinar survey, and we'll be sure to include you in that drawing. I'd like to thank GitLab for sponsoring our program today. And I'd finally like to thank you, our audience, for joining us today. We appreciate you spending an hour with us here at Techstrong Learning, and we hope to see you at a future Techstrong Learning Experience. Have a great rest of your day, and you may now disconnect everyone. Thanks again, guys.